Hello, my name is Saeed Afan Nadeem, and today we'll be understanding about some of the very basic components used in everyday electronic circuits. So the book we'll be looking from is Open Circuits: The Inner Beauty of Electronic Components. We'll start off easy by discussing a very basic switch known as a very basic component known as toggle switch. You must have seen it in many places. So mechanism inside the toggle switch is surprisingly simple. With the flick of a finger, a toggle switch flips back and forth between two positions, connecting a common center lead to one of two internal contacts. Electrical current is therefore routed to one of the two possible paths. The plastic finger that presses down on the metal bar is spring-loaded so that it snaps on either position and provides consistent pressure between the bar and the contact. Being plastic, it keeps the lever that you touch electrically insulated from any voltage that may be on the terminals. Similar toggle switches may add an off position in the middle or additional poles independent sets of contacts that are switched in parallel by the same lever. The second component is also very similar to the first one. This is slide switch. It's almost the same as toggle switch. You must have seen it somewhere like toys or other stuff. As you can see, the position slide switch shown here has small ridges on its handle, making it easy to grip with your fingertip and move it from one position to the other. Inside the handle slides a metal contact plate back and forth, completing a circuit between the middle terminal and one of the two outer terminals. Larger and more complex slide switches may add additional terminals and positions for the sliding handle. As you can see, this is push button switch. It is also a basic switch. You must have seen it somewhere. It is also used very often in many projects, hobby projects or toys and stuff. The basic push button switch is often found on the front panels of hobby electronic projects. Though it isn't typically used in commercial products, still its basic principle of operation applies to other more common types of push button switches. Pressing down the spring-loaded button moves a metal washer against two contacts, connecting them and completing the circuit unless the button is pressed. Again, a very basic component used in almost everything is wire. There are two types. There are commonly used two types of wires: a solid and stranded wire. Wires are everywhere. They are at the bottom of the ocean and in distant space probes. They move electrical signals through our walls, across continents, and sometimes even within our bodies. There are two basic types of wire: solid and stranded. Solid wire has a single filament of metal, while stranded wire consists of multiple smaller wires nested together. Seven strand wire is common because the overall shape is roughly circular. For the same reason, you can also find wire with 19, 37, or even 61 strands. Stranded wire is more flexible, while solid wire tends to hold a shape but break if it's bent many times. Wire can be made with any number of different metals, but copper is the most commonly used in small electronics. To prevent electrical short circuits, wire is often covered with insulation such as varnish, PVC plastic, or even cloth. Another type of switch is mercury tilt switch. Although it is somehow obsolete nowadays, but in the simplest of switches, a tiny blob of conductive In the simplest of switches, a tiny blob of conductive liquid mercury metal can complete an electrical circuit by making contact with the two electrodes, but only when the device is upright. When tilted downward, the mercury falls away from the electrodes, opening the circuit. These switches are no longer readily available due to mercury's toxicity, but years ago you could find them in simple electromechanical thermostats. The mercury switch was secured to the end of a coiled bimetallic strip. Heating or cooling the strip rotated the mercury switch until, at a set temperature, the switch closed. Heater or AC turned on. The next component is incandescent light bulb. This light bulb is a hot tungsten light bulb, which is also somehow obsolete nowadays because LED bulbs have because the LEDs have taken over, but it was also a part of electronic circuits basic part of electronic circuits. Another reason of these light bulbs not being used very much is because they are not efficient. They take up so much power, and that is the reason they are being replaced by LEDs. This light bulb is a classic light where a hot tungsten filament glows simply because it is hot. These bulbs aren't particularly efficient as light sources because so much of their power output is released as heat rather than light, which is why they're now being replaced by LEDs. The filament of the bulb at first glance or even under moderate magnification appears to be a single coil of wire. Under high magnification, however, it turns out to be a coiled coil of much finer wire. The ends of the filament are cool enough, but they don't glow, in part because the two vertical supports act as heat sinks, wicking the heat away from the ends of the filament. Switching on the light bulb generates a thermal pulse which puts a lot of stress on the filament, which is why light bulbs preferentially burn out right as you throw the switch. Next component is a 7-segment LED display. Display is old and not very much used nowadays. It is also being replaced by LEDs, but it was used on large scale back in time. One surprising thing about a 7-segment LED display is how tiny the actual LEDs are in comparison to the overall device. At the base of each D-shaped colored plastic lens sits a small LED chip. These are about the same size as the LED dies in the red through-hole LED, but the packaging here is much larger. The LED dies are mounted chip on board style to a small circuit board. Fine bond wires make connections from the dies of the copper traces on the board, which bring the drive signals in from the large metal pins. The board itself is single-sided, made out of a black fiberless substrate to minimize reflections. The circuit board assembly is placed into the white out frame made from injection molded plastic with black paint on the front surface. Finally, the assembly is filled with red tinted epoxy resin that hardens into the visible lenses of the device. The next component is capacitor. So capacitor comes in every shape and size. For example, this ceramic disc capacitor, or this glass capacitor, or this aluminium electrolytic capacitor, maybe this film capacitor. But the basic principle of every capacitor is the same. It is to store electrical energy in an electric field between two plates separated by an insulating material. This stored energy can be released as current when connected in a circuit. The ability of a capacitor to store charge depends on the size of the plates, the distance between them, and the material between them. Capacitor uh, Capacitors are often used in circuits for filtering and energy storage. The next component is known as potentiometer. You Potentiometer are used in so many things, such as to regulators to control the speed of your fan, or they are used on radios and speakers and your car's audio system to control volume. Potentiometers are basically adjustable resistors. Plots are used as front panel control knobs and everything from laboratory instrumentation to guitar amplifiers, anything where you turn a knob to adjust a setting. The large pot is made of resistive wire wrapped around a ceramic form, an old design essentially unchanged since 1925 and still in production today. Component is a Category 6 Ethernet cable. The Category 6 Ethernet cable contains four twisted pairs of copper wire. These common cables are used worldwide to carry local network and internet traffic. Category 6 table improve on previous generation of cables by adding an internal X-shaped plastic spacer to keep the pairs of wires apart from each other, reducing the signal leakage between pairs. They also have a metal foil shield around the outside to reduce interference from external signals, as well as a separate drain conductor to assist with shielding. The next is SATA cable, or serial attachment cables, or serial at attachment cables used inside computers to connect internal storage drives to the motherboard. Each cable contains two twin axial pairs. One pair carries data to the hard drive and the other pair carries data from the hard drive. A twin axial cable looks like two coaxial cables stuck together sharing the same outer shield. Signals are transmitted with differential signaling, meaning signals are represented by the voltage difference between the two wires. This system effectively cancels out most electrical interference since the interference adds equally to both signal wires. The next component is VGA cable. Video graphic array cables were used in old times before HDMI or DisplayPort cables. They were used to carry video signals from computers to monitors or LCDs. VGA uses analog video signal consisting of three electrical signals representing the color components red, green, and blue. For the two VGA cables shown here, the manufacturers have helpfully color coded the three miniature coaxial cables that transmit these signals. One of the cables also contains a smaller gray coax for transmitting horizontal synchronization information, but the other VGA cable uses a regular wire for the same purpose. VGA cables also have other wires used for other sync signals and to transmit auxiliary information such as data to identify the monitor. VGA cables were used in old times. Now we have HDMI cables, also known as high definition multimedia interface cables. These cables connect computers and other video devices to monitors and televisions. The cable has four independently shielded twisted pairs of cables that transmit the stream of video data gets split into four separate streams of serial digital data, one per pair of wires. At the video monitor end, the four streams are combined and decoded to generate the picture. Outer unshielded wires carry low speed auxiliary signals that identify the make, model, and resolution of the display or allow remote control of volume and other settings. The overall cable is shielded with layers of aluminum foil and a copper braid. Basic USB cable, it is used in almost everything, used to charge everything. If you've used a computer recently or even just charge your phone, you've probably used a USB cable. Cutting into a USB cable and connector reveals a number of interesting details. The plug uses insulation displacing contact similar to those that we saw in the ribbon cable. A pair of tiny metal teeth pops through the insulation of each wire and makes electrical contact with the conductive copper inside. Within the cable, we can identify two larger red and black wires that carry power, as well as two smaller white and green signal wires. All are 7-stranded wires. The larger wires are made with larger strands rather than additional strands. Layers of wrapped foil and aluminum braided wire shielded the signals, preventing interference. The outer protective jacket is made of PVC plastic. USB jack, where the basic type A USB cable inserts. This is the gold-plated contact fingers in the USB jack act like springs pressing down tightly against the flat metal braid contacts inside the plug. Spring fingers on the outer shell lock into recess of the plug, helping to prevent the cable from falling out after it's been plugged in. The clicking sensation you feel when you plug your cable comes from these comes from these spring fingers. If it ever feels like it takes several tries to plug in a USB cable, that's because of these spring fingers. You had it right the first time, they were just a little too stiff. Next is neon lamp. A neon lamp contains a small amount of eponymous noble gas. When enough voltage is applied between the lamp's two parallel electrodes, the gas ionizes and emits a distinctive orange glow. The outer glass envelope holds the electrode in place and prevents the neon gas from escaping. The blob of glass the blob of glass at the tip is where the envelope is sealed. After introduction of the gas during the manufacturing process, when a DC voltage is applied across the leads, only the negative electrode lights up with an AC voltage while alternates between positive and negative polarities many times per second. Each electrode lights up in turn due to persistence of vision. Both electrodes appear lit.